Good evening. This is our classroom, and I'm Mr. Williams, and today we'll be looking at the idea of probability and statistics. And if we look at the concept of statistics, it generally deals with the idea of categorizing data or collecting some type of data. And based upon that data, we're going to be figuring out what is most likely to occur as we categorize the data and look at the data as it is randomly distributed. Today's lesson is going to involve the idea of what we call the randomness of colors that might be found in packages of M&Ms. Many of the class has understand, and you're familiar with M&M packages, the plain. And in the plain, believe it or not, based upon the M&M website, that there are randomly distributed colors within each package of M&M. And based upon us counting those colors, we can determine whether the colors and the expected amount that M&M says are in each package of colors, whether those colors are blue, brown, green, orange, red, or yellow. We're going to see if it's true, based upon M&M's website, that 24% of the color blue is in each package, that 13% of the color brown is there, that 16% of the color green, that 20% of the color orange. Red is represented primarily by 13 and 5 packages of M&Ms, and we're going to determine the actual amount or actual quantity and percentage of each color and how that deviates from the actual M&M website. So we want to check out M&M and see if they're consistent, and we're going to see what the probability is, and we're going to determine with a function called chi-square of the actual deviation. Is the amount or difference between what is actually expected, counted, that we can actually observe? Is it in the deviation of comparing it to what is expected? Is that deviation based upon randomness in each package, or are there some other factors involved? And one way that we do that, students, today is we look at our two students today. We're going to ask and pose a few questions to you. Who basically understands from M&M times the actual quantity, okay, in each package. Okay, and that's going to give us what's expected. And then we're going to count the observed. Okay, that's a count. Okay, and then we're going to be looking, after we get the expected and observed, we're going to be looking, and one of the actual points in your table that we're going to be looking at is going to be the difference, okay? And then we're going to take the difference and divide it by the expected to calculate the chi-square. Once we get the chi-square, we're going to be using a common reference table that lists chi-square values, and then we're going to be looking at the probability of the deviation between what is expected and then what is observed. Okay? Now, I'm going to ask, and we're going to be very quick with this, and I'm going to ask we're going to go here, and we're going to ask one of the students to come up and get the quantity, and we're going to do each package at a time. Just get one package of the M&Ms, and we're going to spread them out on the table. Okay? Spread them out, and Jeremiah, we want you to help. And we're first of all, we're going to count the total number of M&Ms. On a table, and we're going to have you write, okay? Okay, and let's write the total number. We're going to have package 1. Okay, and we're going to look at total number. Okay, and I want to list that. The total number is what?
56.
56. Very good. Okay, and then you want to count each color.
Okay. We have 9 red. 12 orange. 13 yellow. 9 brown.
And we want to get a good look at this chart as we're going to be figuring out in column 1, we're going to be looking at the expected. And the expected amount would be each color, and let's write each color on the board. We're going to have colors. Okay, and to fill out the first column, which is the expected amount, we're going to have we're going to put orange first. Okay. Okay, and the actual amount and expected amount of orange, okay, we're going to put E of orange, okay, is going to equal to the percentage. And I want to I have to give you the percentages from the M&M website, and I want to make sure we get those quantities for you. Okay, for orange, M&M has 20%. So 20%, okay, times the total number is equal to the expected amount of orange. And so we know here that 20% is what? 0.20?
Yes.
Okay, times total is 56. Okay, and do you have your calculator, students? And let's get an idea. We're going to, out of 56, okay, the expected of orange is about what? 11. So we have to use, and we have to be approximate, so we expect at least what? 11 of the orange. The same, now let me put these percentages on the board, and I'm going to have you figure out and fill in the table for expected. Okay? And then you already have seen what you put in for observed. So we want to look at the table again. And so the expected column, you're going to take each percentage, and I'm going to put the percentages on the board for you, students, and we're going to be using that to calculate so we're going to enter very quickly the expected amount of orange would be 11. So we're going to put that in there. 11. Okay. The actual number of orange in the first bag is what?
1, 2, 3, 4, 5, 6, 7, 8, 9. On the board. I'm going to leave this example up here, and I'm going to write the percentages.
according to M&M, the percentage of blue, okay, that's expected is approximately 24%. Okay, the expected amount of brown, okay, is approximately 13%. The expected amount of green is about 16%. The expected amount of red in each package is approximately 13%. Okay, and then expected amount of yellow, okay, is approximately 14%. Okay, so we want to figure out, and you talk among yourselves, and we want to figure out those quantities. Jeremiah, we want you to help out with that. Now, what are you going to use as an equation, class? What are you going to use as an equation?
We're going to use the percentage times the total amount to get the number of the expected number of M&Ms in each package.
Okay, all right.
Get the percentage, so we're doing red. The percentage is 13%, so we do 0.13 times 56, which is in total, and we get 7.28. So that'll round to 7 red M&Ms in the package. The next number we go on to is brown. What we do, we multiply 0.13 times 56. We'll get 7. The next number we do is blue, which is 24%. So we'll do 0.24 times 56. And we'll get 13 blue as an expected amount. The next number we do is green. We have 16%. So we'll do 0.16 times 56. 0.15 times 56. And we'll get 8.4. So there it is, 8 expected. The last number we do is yellow, 0.14 times.
And it's very good. So if you're able to use that expected percentage from M&M and multiply it by the actual amount that you get in each package, you're able to figure out the total expected. And then we want to make sure that we put in the actual amount that you have, the actual amount in each next to the other numbers in your chart. So let's get another package of M&Ms, and we're going to be doing that for another. Just write the numbers again here.
There's one on the floor.
Get another package of M&Ms, and we're going to be counting another package of M&Ms.
So what we'll do the same thing how we did before.
Okay, and then you do the same thing that you have before. Okay, now we want to get another estimate, and you can just draw a line here in your chart. Just you put it down. Here we have another sheet of paper for you, and we're going to be figuring this out for the second M&Ms.
So the color orange. So we have 11 actual orange. Red, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Color brown, we have 1, 2, 3, 4, 5. Color blue, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Color green, 1, 2, 3, 4, 5, 6, 7, 8. Color yellow,
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.
14.
Okay, fantastic.
Okay.
Okay, now, we're hoping and you can figure out, and let's get an idea in this particular package what the expected amount would be. So we have a different expected amount, so you want to use the same equation and figure out the expected amount for this bag. Each bag will have a different expected amount because you want to use the total. Now, what are the total for this particular bag? How many do you have in there? And I want you to use the equation to figure out the total, the expected amount in this bag based upon these percentages.
Okay. That's 58 total.
Okay, 58 total. So let's figure out the new expected amount. Put it in. Okay, and we want to use, instead of 56, we want to use what? 58. Doing at this time.
We want to do 13.92, so we round that to get 14. That's for the blue. Next we do the brown. We do 13 times 58, 0.13 times 58. Then we'll get 7. The next number, green, 0.16 times 58. We get 9.28. So we get 9. Next number we do is red. The next color we do is red. Do 0.13 times 58. Get 7. Next number we do is orange. 20%. So we do 0.20 times 58. These are new expected amounts.
Very good. And now we want to take these expected values. Of course, you can do this for the next 3 bags of M&M, but I think we have enough data, student, to apply now our chi-square. And we want to explain basically what that principle is, and we're going to have you do that calculation, and we're going to have to let you get into some results and predicting some probability in reference to the number of M&Ms and the frequency of colors within an M&M package. And so let's take a look at what this idea of chi-square is. As we look on the board here very quickly, we want to get an idea of chi-square. And basically what chi-square is, it compares what you have observed, and we have numbers for what we observed, and via the M&M website we have determined and also figured out the expected value of the frequency of colors of orange, red, brown, blue, green, and yellow. And so we're going to look and we're going to see what, and so basically the formula for calculating chi-square, okay, is, okay, and we put about that, is chi-square is equal to the observable square, the difference between the observable and the expected, and the square of that divided by the expected value. And based upon that number, we're going to see what that number means in reference to predicting the difference between the deviation of whether it's due to a process at M&M or whether it is what it claims to be. The deviation is due to the frequency and probability or expected value of how many colors are in each package, and we're going to use our data to make those determinations. And so, based upon this equation and your table, we're going to figure out, and I just want to get an idea of the table you have already figured out for the first, the difference of the observable amount, which is 12 in this case, 12 in this case, minus 11, and we're going to square that, and then we're going to divide by what was expected, and that's 11, and we're going to fill in this last column and get the chi-square, not only for the first bag, but also the second bag. So as the students get going, you can get your M&Ms off your desk, and we're going to be filling out these last few and figure out chi-square. And I want you to look up here, and just for example, let's help and model this for our students in reference to figuring out this last category. And so, based upon your data, the column for actual, okay, minus the expected. In the first case, your data seemingly would be the actual, you counted was 12 minus 11, okay, and so in that particular column, this would be what? 1, okay, and then the next column, which is the actual difference squared, would also be what? 1. And then the chi-squared is the last column, and we're going to take 1 and divide it by the, you want to use your calculator, 1 divided by the expected amount, okay? And so 1 divided by 11, and we want to use our calculator to do that, okay? We're going to go over, and we're going to say 1 divided by 11, figure out and fill in the charts. Okay, and we're going to see them do this.
So we'll do the actual subtracted by the expected amount. So for the first orange, we got 1. The next for red, 9 minus 7, that equals 2. Brown, 9 minus 7, we get 2. The next amount, we had 4. For the actual and expected was 13. Now, would it be a negative?
It would be a negative.
Okay. So in that case, we have a negative 9.
Okay, because we're going to always square it, right?
Right.
Okay.
The green, we have 1. The actual for the yellow, we have a 6. So after that, we square what the difference was. Right?
Yeah.
So 1 squared is 1.
Calculator. Okay. You can. Square of 2.
Square of 2 is 4. Square of 2 is 4. Square of negative 9 is 81. So square of 1 is 1. Square of 6 is 36.
Okay.
Okay.
Now, let's actual amount minus the expected amount divided by the expected amount.
Okay.
So we want to take the square of this column and divided by the expected amount.
So what we're going to do, we're going to take this column. So this is the actual minus the expected.
Square divided by E.
Oh, okay.
Okay, so we want to divide this last column by the first column.
Alright. So 1 divided by 11, you get 0.09. The next column we have a 4 divided by 7, which gives us 0.57. The next amount is the same thing for column blue, 81 divided by 13, we get 6.23. Next column, 1 divided by 8, we get 0.125.
Now we come to the last part of this lesson. And the last part of this lesson, of course, they could have also figured out the chi-square value for the second bag through the fifth bag of M&Ms. But I think we have the sample from the first bag, and students have already figured out the idea and filled in this wonderful chart of figuring out the frequency of the colors that are expected in each bag, and also the actual observed amount. And now we have figured out chi-square in each of the last column. And then we're going to compare that to making looking at our hypothesis. And certainly our hypothesis is figuring out and knowing whether the deviation, the difference between the expected and the actual amount, observed amount, whether that deviation is due to the randomness of colors within each bag, or use this probability chart. And here's a probability chart that students would be given in this lesson. And basically the probability chart takes first of all, the degree of freedom. And degree of freedom is measured, and I just want to put that on the board here, that we need the degree of freedom to see what row we are in. And that degree of freedom is based upon the total number of objects. And in this case, we have 1, 2, 3, 4, 5, 6 particular colors subtracted by 1, so the degree of freedom would be 5. And based upon our degree of freedom, we would look in our probability chart, which is here, and we would take the chi numbers to see upward in the first particular row what our probability is. And based upon our probability, here is part of our hypothesis class that we're going to compare at this time, is that if the probability for the calculated amount for chi-square 5, and let me put that up here, if the probability based on chi-square that we get for our degree of freedom is basically less than 0.05, okay, then we know that the deviation, okay, in each bag, okay, is due to randomness. Okay, is due to the randomness in each bag. That is due specifically to the randomness, and there is a rejection of the hypothesis, and there's some process issue of why the colors are different in the bag. So we're going to look at that now, and deviation is 5, and we're going to go over to the closest number that's closest to 0.09, and that would be 0.11. We look up the probability of orange is 0.95. And so 0.95 is what? Greater than 0. So we accept the hypothesis and the deviation. And you can see when we looked at orange was almost the same as the expected number. And so we accept the hypothesis, and the deviation in that one bag is due to what? Randomness. And so I want you to go along, and you're going to write whether randomness or the process is due to some process. And so go ahead, and we're going to figure out these particular hypotheses. Okay, let's go. Down, you look at what? 0.57. Go get the probability. What number is closest in degree to 0.07? And then so the probability for that one is what?
The closest number is 0.71.
Oh,
0.71.
You're supposed looking at 5. And so again,
1.14.
1.14. The probability for red is what? Look up at the first row. Go up to the first row.
0.95.
0.95. So according to our rule of deviation, what is that? Is it randomness?
Randomness.
It's randomness. Very good. Okay, you want to write randomness next to that count. Okay, let's go to the next one for brown.
This is the same thing.
It's the same thing. Okay, now look for blue. Let's go look for blue.
23.
And it's 623. And Jeremiah, where do you go on the chart? 623. Okay.
6.06.
Okay, 6.06. Is that close to it? So what's the probability?
0.30.
0.3 what? 0. Is that great?
1.0.
Okay, you want to go to the degree of freedom is what?
0.1.
The degree of freedom is 5, so 0.95. And we go to our deviation, and what is that conclusion? Randomness. Very good. Let's go to the next one.
5.84. 5.14.
5.14.
And we get 5.53. And it is 0.7. So that is also random.
That's also randomness. Very, very good. So what conclusions, students, can we come to by collecting our data and looking at Square in reference to this one bag of M&Ms?
That the number of the actual M&M is due to random.
Is new to the actual random. And we could have gotten some different numbers, but is there any other application that we can apply? One application may be due to